This is a science show, and today we're going to be answering the query: what if we could download knowledge into our brains? Is that possible? And if so, how? What would it look like? To answer this question, we need to first consider how knowledge is stored in the brain. There are about 86 billion neurons in your brain, each capable of forming around 1,000 connections to other neurons. All your knowledge is stored in these connections between neurons. The connections that are made when you learn new things, which means your brain physically changes every time you learn something new. So to download knowledge into your brain, you need to find a way to change these connections between neurons. But how do you do that? To understand how to do that, we need to first understand how current flows through neurons. Neurons are special because they can send electrical signals down their long, thin bodies called axons. Electrical signals are generated by the movement of ions, which are atoms that have either gained or lost electrons. These ions flow through ion channels, which are proteins embedded in the neuron cell membrane. Ion channels are selective for particular ions, meaning that there are different types of ion channels that allow for the passage of different types of ions. When an electrical signal is sent through a neuron, the movement of ions through ion channels changes, which alters the charge of the neuron. This change in charge can then be detected by other neurons, allowing them to fire and pass on the signal. The strength of the connection between two neurons is determined by the amount of electrical signals that are passed between them. The more signals that are passed, the stronger the connection. This is why learning new things makes your brain physically larger. Your brain is literally growing new connections between neurons, which means that you are physically changing the structure of your brain every time you learn something new. So to download knowledge into your brain, you need to somehow change the number of electrical signals being sent between neurons. In the past, scientists believed that this was only possible through Hebbian learning, which states that the connection between two neurons will strengthen if they are frequently active at the same time. For example, if you think about food while you smell it, the neurons that represent food in your brain will become more active. Over time, this will lead to a strengthening of the connection between the neurons that represent food and the neurons that represent smell. But what if I told you that there is another way to change the connections between neurons without having to use Hebbian learning? Enter the neuromodulator. Neuromodulators are chemicals that can bind to neurons and change the way they work. By binding to ion channels, neuromodulators can alter the flow of ions through them, which changes the electrical properties of the neuron. This can make it more or less likely for the neuron to fire an electrical signal. In other words, neuromodulators can change the amount of electrical activity in a neuron, which can lead to changes in the strength of connections between neurons. Some examples of neuromodulators include dopamine, serotonin, and acetylcholine. Scientists are still discovering all the different ways that neuromodulators can affect neuronal activity, but it is clear that they play an important role in learning and memory. Neuromodulators can also be used to target specific types of neurons, making it possible to download specific types of knowledge into the brain. For example, dopamine is a neuromodulator that is released in the brain's reward system when you do something pleasurable like eating delicious food or completing a challenging task. Dopamine binds to specific receptors on neurons in the reward system, which increases the activity of those neurons. This increased activity strengthens the connections between neurons in the reward system, which makes it more likely for you to repeat that behavior in the future. So, what does all this mean for downloading knowledge into the brain? It means that we may one day be able to develop a technology that can artificially stimulate specific types of neurons using neuromodulators. This could potentially allow us to directly influence the strength of connections between neurons, making it possible to download specific types of knowledge into the brain. There are already a number of technologies that are being developed that could potentially be used to stimulate specific types of neurons. One example is deep brain stimulation, which is already being used to treat conditions like Parkinson's disease and epilepsy. Deep brain stimulation involves implanting electrodes into the brain and then delivering electrical pulses to specific areas of the brain. Another example is transcranial magnetic stimulation, which uses magnetic pulses to stimulate neurons in the brain. Both of these technologies are currently being used to treat neurological conditions, but they could also potentially be used to stimulate neurons in a non-invasive way. So, what would this look like in practice? Let's say that we want to download the knowledge of how to ride a bike into someone's brain. We could potentially do this by developing a neuromodulator that stimulates the neurons involved in motor control and balance. This neuromodulator would artificially increase the strength of the connections between the neurons involved in these functions, effectively downloading the knowledge of how to ride a bike into the brain. Of course, this is just one example of many different ways that neuromodulation could be used to download knowledge into the brain. Other possibilities include downloading knowledge of a foreign language or downloading procedural memory, which is the type of memory that allows us to perform complex tasks like riding a bike. The potential applications of neuromodulation are truly endless. But what are the ethical implications of such a technology? If it were possible to download knowledge into the brain, what are the potential risks and benefits? How could this technology be used to improve people's lives? And what are the potential unintended consequences of using neuromodulators to manipulate the brain? These are all important questions that need to be considered as we continue to develop new technologies to stimulate neurons in the brain. While the idea of being able to download knowledge directly into your brain may seem like science fiction, the reality is that it is becoming more and more possible as our understanding of neuroscience and neurotechnology grows. Who knows? Maybe one day soon, we will be able to learn new things simply by downloading them into our brains. But what do you think? Is downloading knowledge into the brain something that you would ever want to do? Let me know in the comments below. And if you enjoyed this video, make sure to hit the like button and subscribe for more science videos. Thanks for watching. See you next time.